Hey guys, this is Mr. Guiding. Just a reminder that the videos are best played at 1.25 speed as Google and YouTube tends to slow down my voice. Okay, so we're starting a new unit here today that includes a topic that is a lot easier to understand once you've understood universal gravitation. What we're looking at here is a unit called electric charge. And we're going to talk a little bit about what you already know and kind of expand on your knowledge of on that. So you remember when you were at home when you were younger and you had birthday parties, and you'd rub the balloon on your hair and stick the balloon to the ceiling or to the wall. That's much more than a mere magic trick. That actually is the structure of what we're going to be looking at today. So when you're taking the balloon and you're rubbing it on your hair, what you're actually doing is you're stripping your hair of electrons and transferring them onto the balloon. So the balloon starts out neutrally charged. Your hair is neutrally charged, and the rubbing motion actually lets the electrons jump onto the balloon. Now, let's talk about what charges are. So, a standard picture, which is, by the way, not so accurate, I'm going to talk about that shortly, of an atom is the fact that the atom has this nucleus inside, and this is a positively charged nucleus. And again, this picture is not to scale, but around the nucleus we have tiny particles that are negatively charged, and these are called electrons. Okay, so when we look at a substance such as hair or silk or wool or a balloon, normally these charges are balanced, meaning if there is an electron, there's we'll say one electron, then there's one proton, a positively charged. So as you're about to rub the balloon on your head, if you were to touch the balloon to the ceiling or to the wall, you would notice that the balloon would not stick to the wall before you rub it. So you rub it, and then the balloon sticks to the wall. So just a little history. It's been known since ancient times that when certain materials are rubbed together, they develop an attraction for each other. And what this can be said as, you guys can realize that when you take the clothes out of your dryer, the clothes stick to each other. In ancient Greece, people noticed that when the thread was spun over a spindle of amber, that the thread was attracted to the spindle. And so you guys have seen this happen quite often in your everyday lives. Now, the only difference here is that we're going to get into it a little bit. And the Greek word for amber was electron. Electron. Hence the force was called electric force. So we're going to get into something called electric charges. And so let's take a look at the atom again. Okay, here's the nucleus. Here is the electrons on the outside of this atom. Now I'm going to just give you the basic properties here. Okay, let's call this a positive charge, and let's call this a positive charge. We're not going to talk numbers yet. We're just going to talk concepts. So a positive charge and a positive charge always repel each other. Okay, so they'll never touch. They always repel. In fact, if they touched, it would be like on Back to the Future. If you've ever watched that, I know you guys probably have, but there would be a catastrophic, cataclysmic event, according to Doc Brown. Now here's your two positive charges. They repel, and likewise, guys, two negative charges will also repel each other. Okay, this is a basic concept. Now, if I take a positive charge and a negative charge, okay, the positive and the negative are actually going to pull towards each other. Okay, so these repel, this repels, and this attracts. So let's just take a peek at exactly what happens when we are looking at charged particles. So I'm going to give you a substance. Let's call it that balloon that we were going to charge up here. All right, here's an inflated balloon. Okay, and I'm going to put some charges inside that balloon, and we're going to say that they're kind of spread out evenly, you know, and we're going to say that the balloon has 2 positives and 2 negatives on there. Okay, let's say and again, it's tough to teach this here this way because in class I'd actually be doing this with you guys. You know, remember that machine that I showed you guys that zapped you? I'm kind of glad that I did that out of order because now you can kind of understand what electrons do because we're not going to be able to see that this year. So here's the deal. Let's say we got a balloon with positive charges here and negative charges. Because the amount of charges of each are equal, we're going to say that this is neutral. Okay, neutral. They cancel each other out. There's no net charge. Now, let's say I have an object here. Okay, an object here. We'll call this a metal rod. I'm going to put it close to this. And let's say that that this also is neutral. Now, something interesting happens. Now, when I take these two objects and I make them interact with each other. First of all, the energy that I have when I rub this object on this object, the energy actually allows for the transfer of electrons. So if I rub these objects together, okay, the result, again, forgive the drawing, may be something like this. Okay, so and let's see. If I have 3 electrons here and 2 protons here, that means that I must have 2 protons here and 1 electron here because one of them left here. So now this object or this balloon becomes negatively charged, and this object here, doesn't matter what it is, it could be a comb or a rod, becomes positively charged. Now, I don't want this video to get long-winded. I'm going to try to keep it under 10 minutes, but let's just see what happened. Overall, if I look at the whole system, I haven't done anything to the system. All I've done was take and transfer charges. Now, I've actually added negative charges to the balloon. Have I taken away any positive charges from this? No. All I've done was I've added negatives from this onto there. Now, this has more positives and this has more negatives. So this one is said to be negative charged, this one is said to be positive charged. But overall, look at the whole picture. The whole picture is still neutral. If we were to draw like a big circle around this whole thing, all we've done is we've just transferred charges. So then you might ask, you say, well, hey, Mr. Gagnon, why then does the balloon stick to the wall? Well, here's the reason. So if I take this balloon away from this bar, and I go and I've got this balloon right here. Okay, here it is, and I know that there are negative charges and positive charges, and I know. Let's say that this is the wall that I'm going to try to stick it to. The wall has positives and negatives as well. Okay, and the wall is generally neutral. So if I go and I put this balloon close to this wall, something pretty cool happens with the configuration of the charges on each. Now look, if I have a balloon here that has negatives on one side of the balloon, what's going to happen is, see, these negatives, they repel each other. So if the negatives repel each other, these negatives from this balloon are going to push these negative charges on the wall away from the balloon, and thus making the wall more positively charged on one side. So if this pushes the electrons over, now these guys want to come in contact. They're very attracted to each other. Okay, they have an attraction. So if this is still lined up where negatives are on this side, guess what's going to happen? Well, if I put the balloon to the wall, then, well, these two are going to want to come into contact with each other. And so the balloon will actually stick to the wall. And that's how that old trick actually works. Now, I'm going to stop the video now. We're at about 10 minutes. That's as far as I want to go with that. I'm going to talk a little bit more about how this actually happens and some terminology, and maybe get into a little bit of the math.